Hi everyone, welcome to the online classes. I am so happy to see you through the online classes. This is Rajesh, I am your physics teacher. Last class, we have seen the lessons about the natural world of and measurements. In this class, we have discussed about what do you mean by physics and how they are related in our day-to-day life and measurements. Measurements, how we can find some cases of physical quantities, the physical quantities, how to relate it in our day-to-day life. So let's see elaborately. In the first topic, we can measure the topic of measurement of length. The length is the one of the physical quantity which can be used to measure the distance between some of the distances. Some distances, the length can be classified in microsome and macrosome. The macrosome is nothing but we can measure the distance of very large objects, and microsome is very small distances can be measured by using of the quantity using the terms of microsome. And then a small distance can be measured by the using of devices of screw gauge, like this screw gauge and vernier caliper. And we can measure the large distances, which means we can measure the distances from the earth to the planet. We can using of variation methods like a triangulation method and parallax method. Parallax method which helps to determine the distance between moon from the earth. We can measure the large distance by using a parallax method. And finally, we can measure the topics of radar method. So radar method based on the principle of radio echoes and how they are related in our day-to-day life. Let's see. Thank you.
Okay, good. Today we have see the first lesson of first topic of measurement of basic quantities. In this session we have studies about the first one, length. Yes, length. The concept of length in physics is related to the concept of distance in everyday life. We know that every distance can be measured by using the scale of meter. So the length can be measured with the help of the unit of meter. And also the SI unit of length is meter. The object is more interested very widely in sizes. For example, large objects like galaxy, stars, sun, earth, moon, etc. And the distances constitute macrosome, which are the object will be widely varies with very large size. We can study about that particular content will be called as macrosome. So then another one, in contrary, objects like molecules, atoms, proton, neutron, electron, bacteria, etc. and the distance are constitute microsome, which means a small world in that both objects and distance are small sized. So we can the objects can be classified in two types, namely macrosome. The macrosome will be tells us object in very large sizes or distances. Microsome means very small sizes. Distances ranging from 10 power minus 5 meter to 10 power plus 2 meter can be measured by direct methods. For example, a meter scale, we know that we are measuring distance day-to-day life by using of meter scale. For example, a meter scale can be measured a distance from 10 power minus 3 meter to 1 meter. And by using a vernier caliper to measure of 10 power minus 4 meter. And by using of screw gauge up to 10 power minus 5 meter and so on. And the atomic and astronomical distance cannot be measured by any of the above mentioned direct methods. Hence, we can measure the very small and very large distances in direct methods. We have devised an usual table 1.4. Table 1.4, prefixes of powers of 10. 10 power 1 is called as a deca and its symbol DA. 10 power plus 2 hecto and its symbol H, small h. 10 power plus 3 is called as kilo, so referred as small k. 10 power plus 6 is called as mega and its symbol capital M. 10 power 9 giga and its symbol capital G. 10 power plus 12 tera and its symbol capital T. 10 power plus 15 peta and its symbol P, capital P. 10 power 18 prefix exa and its symbol capital E. 10 power 21 zeta and its symbol capital EZ. 10 power 24 iota and its symbol capital Y. Similarly, powers of minus, this means submultiple. 10 power minus 1 is called as deci and its symbol small d. 10 power minus 2 centi and its symbol small c. 10 power minus 3 milli and its symbol small m. 10 power minus 6 prefix of micro and its symbol mu. This is a new word of mu. 10 power minus 9 nano and its symbol small n. 10 power minus 12 pico and its symbol small p. 10 power minus 15 femto and its symbol small f. 10 power minus 18 arto and its symbol a. 10 power minus 21 zepto and its symbol ez. 10 power minus 24 acto and its symbol capital Y. Next topic, measurement of small distances by using of screw gauge and vernier caliper. The screw gauge is a device which is used to measuring accurately for the dimensions of object up to a maximum of about 50 millimeter. And also, screw gauge is a device which is used to measure the diameter of a thin wire. We can measure the diameter of thin wire by using of screw gauge. In this device, worked based on the principle of circular motion of screw. Like as a screw, we can rotate the screw will be rotated at a particular rotations. So, in this principle of magnifications of linear motions by using of the circular motions of a screw, and its least count of the screw gauge is 0.01 millimeter. This is a more important one, 0.01 millimeter. And then in this diagram, the following diagram will be see. There are two scales will be using. One of us, this scales will be called as pitch scale. This scale will be called as head scale coincidence or circular scale maybe. The scale will be rotated, whereas in this process, the pitch scale reading and head scale reading also coincide with 0 to 0. There is no error, this one. And in case of the pitch scale reading will be indicated 0 and circular scale will be indicated 5, which means exceeds of above 0. So this error will be called as positive error. And here in this concept, the pitch scale will be in the process of 0. The head scale coincidence will be below 0. So the error will be called as negative error. And the second device, vernier caliper. We have seen in laboratory process in previous standard of 10th standard maybe, or we can study in this in our classes. So vernier caliper. So vernier caliper is a versatile instrument for measuring the dimensions of object, namely diameter of the hole or depth of a hole. The least count of the vernier caliper is 0.1 millimeter. 0.1 millimeter. And the next, measuring of large distances. For measuring large distances such as the height of the tree, distance of the moon, or a planet from the Earth on some special methods are adapted. For us, triangulation method, parallax method, and radar methods are used to determine very large distances. First of all, we can see the methods of triangulation method, which the purpose we can using of the triangulation method is height of an accessible object. See the diagram clearly. First, here in this session, AB. Here, AB is the height of the tree or tower to be measured. And then let C here. Let C be the point or distance x from B. Here, at the point of C is fixed with the observer. The observer was standing at the positions of C. Here, the observer will be here. And then a place of range finder at C measured the angle of elevation. Angle of elevation A, C, B is theta. ACB equal to theta. From the right angle triangle, we can measure. From the right angle triangle ABC, here the diagram. From the right angle triangle ABC, we can measure the tan theta. We know that already tan theta equal to opposite side here. Opposite side by adjacent side. Opposite side is AB, so we can write as AB, and adjacent side is BC, so we can write as BC. We know that AB is H and BC is X, so we put the value of AB and BC in these equations, and we can measure the value of H, height. So H equal to, we can multiply the terms of X into tan theta. So H equal to X tan theta. This is the equations. So we know the value of angle and the base value, so we can measure easily the height value. Next method, parallax method. Parallax method is used to measure the large distances, like as the distance between a planet or star from the Earth can be measured by the parallax method. Parallax is the name given to the apparent change in the position of an object with respect to the background when the object is seen from the different position. The distance between two positions is called as basis. For example, consider an observer is specified the position of O. The observer holding a pen before him and against of the background of the wall. When the pen is looked at the first our left eye L, closing the right eye, and then by our right eye closing the left eye. The position of the pen changes with respect to the background of the wall. The shift in the position of an object, the object will be say is pen, when the view with the two eyes keeping one eye closed at a time is known as parallax. The distance between the left eye and the right eye is called as basis. Is nothing but simply tells us we take as a pen. The pen is stand before on the wall. So we can see the pen, one eye is closed, like as our left eye is closed when the right eye is open. The pen is stand by one position. Suppose we can close the left eye, the right eye will be open. So the pen will be changing its position with the background of the wall. This is called as parallax. So this method is called as parallax method. So the angle of LO, or here the diagram will be this. The angle of LO, or the angle of LO or is called as parallactic angle. Here the terms of in this position, here L or be the length of the length, and B be the distance between L and R. So LO in this session, LO and RO are equidistance, which is x, here x. So we can find the theta. We know that theta, according to theta, we can measure opposite side of b and adjacent side is x. So theta is b by x. So we know the value of b and x, we can measure the theta. Or we know the value of theta and b, we can measure the value of x. So x equal to b by theta. So we can easily measure the value of, know the some two values easily. Next topic, determinations of distance of moon from earth. Here in this position the moon will be placed here, and in this sector, in this position will be the earth. So we can measure the distance between moon and earth. Okay, here in this point A and B, here A and B, the process of A and B, diametrically opposite places of the surface of the earth. From A and B are parallax with the angle of theta 1 and theta 2 respectively from the moon. We can measure the distance of moon or star with the help of the astronomical telescope. And this point here, thus the total parallax moon subtended on the earth, the angle of A and B equal to theta 1 plus theta 2 equal to theta, is nothing but, we know that the properties of angle is sum of the interior angle theta 1 plus theta 2, sum of the interior angle which is equivalent to the exterior angle. In this point, the exterior angle theta 1 and theta 2 are the exterior angle, theta be the interior angle. So we can measure the value of angle of A and B equal to sum of the exterior angle equal to interior angle. So theta is measured as radians. So we can measure the similar way of theta. So theta equal to opposite angle of AB and adjacent side is opposite side is AB and adjacent side is AM. So we can measure theta equal to AB by AM. In this point, whereas AM is approximately equal to, in this point AM is approximately equal to MC. So theta equal to AB, AM replaced as MC, so theta equal to AB by MC. So we can measure the distance between moon and earth. So MC, we can record the value of MC. So MC equal to AB by theta. So all the values of known of AB and theta we can measure easily MC value. Next topic, radar. Radar is a device which means radio detection and ranging. The device works on the principle of radio echoes. Radars works on the principle of radio echoes. A radar can be used to measure accurately the distance of nearby the planet, such as Mars. In this method, the radio waves are sent from the transmitters, which are after reflection from the planet and are detected by the receiver. By measuring the time interval t between the instant of radio waves are sent and received, the distance of the planet can be determined as speed equal to distance traveled by the time taken. So we can write as d equal to v into t by 2, whereas v is the speed of radio wave, which is equivalent to velocity of light. The distance covered during the forward and backward path of the radio waves is divided by 2. So simply tell us radio. Okay, good. This is the device of radar. So in this device, radar consists of two elements, namely transmitter and receiver. The radar will be transmitted the radio waves in this due to the devices of transmitter. So the waves are transmitted during the transmitter, and the transmitted wave will be reached to the planet or objects after reflection. The reflection waves will be reached at the receiver. This is transmitter, this is an receiver, to reaching the receiver. So the time duration, this is moving of one time duration, take as t equal to 1, this is t equal to 2, this is twice times, one time and twice time. So we can write as the equations d equal to v into t by divided by 2. This is, so we can actually get the distance of the object. This is the method can also use to determine the height in which of the aeroplane flies from the ground. This is the radar. Thank you.